Good morning, students. Continuation to the same chapter. In the last class, we have dealt with uniform and non-uniform motion, speed and velocity, distance and displacement, and acceleration and retardation, and also the units we have discussed it. Now, today we will discuss four things. Number one is equations of uniformly accelerated motion. Second one is the mass of the body. Third one is the weight of the body. So what is weight, what is mass? Okay, we'll discuss it, and also the change in the value of acceleration due to gravity. So these four things we'll discuss it today. Now the first one is the equation of uniformly accelerated motion. Now when a body is moving in a straight line, or when a body is having a linear motion, linear means which moves in a straight line. For when a body is moving in a straight line with uniformly accelerated motion, the motion is uniformly accelerated and the body is moving in a straight line. In that case, the equations will be there. There are three equations. And this equation gives the relation between the initial velocity, final velocity, time, displacement, and acceleration. So this equation also gives the relation between the initial velocity, final velocity, time, displacement, and acceleration. Okay, now the first equation is, number one is V equals to U plus AT. The first equation is V equals to U plus AT. So V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time. Okay, and initial velocity is the starting velocity. Okay, when a body starts moving, okay, with some velocity, and that velocity is the initial velocity. And when a body attains after moving, when a body comes in the state of motion, and after some time when a body attains the velocity, the sudden velocity, that velocity is the final velocity. And always the final velocity is more than the initial velocity. Initial velocity is less, final velocity is more. And when a body starts from rest, when a body is at rest, and when a body starts from rest, in that case, initial velocity will become 0. Initial velocity will become 0 when a body starts from rest. Okay, for example, I will give you a car. A car is in the state of rest, and when a car starts moving from rest, then the initial velocity will become 0. Second one, when a moving body finally stops, when a body is moving and that moving body finally stops by applying a brake, in that case the final velocity will become 0, that is V equals to 0. V equals to 0 when a moving body stops by applying brake. Initial velocity will become 0 when a body starts from rest. So remember these things. Okay, so the first equation is V equals to U plus AT. Second one is S equals to ut plus half AT square. Second equation is S equals to ut plus half means 1/2 AT square. S means the distance, U is the initial velocity, T is the time, and A is the acceleration. Third one is here V square equals to U square plus 2AS. The third equation of motion is V square equals to U square plus 2AS. V square means final velocity square equals to initial velocity square plus 2 times or twice the acceleration into distance or displacement. Okay? So these are the three equations of motion. But when a body is moving with retardation, or when the retardation is produced in a body, retardation means when the velocity decreases. So when the retardation is produced in a body, then the same equation of motion will change. Change means there is no change in the equation, but only there is a change in the sign. Okay, when a body produces retardation, in that case, the first equation will be V equals to U minus AT. V equals to U minus AT. Now, how this minus A is coming? Because retardation is produced, you know that retardation is known as negative acceleration. Retardation is written, the symbol of retardation is minus A, and acceleration is A, small letter A, and small letter minus A. So how this equation comes here? V equals to U, I write it plus, then minus A into T. Now, since the retardation is produced here, so I write it minus A here. So V equals to U plus into minus will be minus A T. So this way the equation has come here. Okay, only there will be the change in the sign when the retardation is produced. Similarly, second equation, S equals to ut minus, instead of plus, minus half at square. Third equation, v square equals to u square minus 2as. Okay, so this way you can represent the equation of motion. Okay, when a body is moving with a uniformly accelerated motion, when a body is having retardation. So these are the three equations of motion. Okay, so these three equations of motion we have to remember it when you solve the numericals. And when the value of u is 0, when the value of v is 0, remember that. Okay, so these are the first term is about the equation of uniformly accelerated motion. Now the next one is change in the value of weight due to change in acceleration due to gravity. Now the value of acceleration due to gravity is 9.8 meter per second square. But the value of acceleration due to gravity varies or changes when we go to the different places on the Earth's surface. Okay, so when we move from Chennai to Kolkata, okay, from one place to another, the value of acceleration due to gravity changes. And the value of acceleration due to gravity, when it changes, so change in the value of acceleration due to gravity will bring the change in the weight. Okay, so therefore weight equals to W equals to M into G. So when there is a change in the or when there is a variation in the acceleration due to gravity, then there will be a change in the weight. And the acceleration due to gravity is maximum at the poles and minimum at the equator. Maximum at the poles, minimum at the equator. Okay, so at the poles, the value of acceleration due to gravity at the poles, the value of acceleration due to gravity is 9.83, whereas in the equator, the value of acceleration due to gravity is 9.78 meter per second square. Okay, so these are the difference in the poles as well as in the equator. In the poles, the value of acceleration due to gravity is 9.8, which is greater than the equator. Okay, and when a body is taken above the equator or below the equator, okay, the value of acceleration due to gravity changes. Either you go upward or you move downwards, the value of acceleration due to gravity changes, and due to change in the value of acceleration due to gravity, the weight of the body will change or the weight of the body get reduced. So therefore, we can say that weight of the body is changing or it gets changed due to the change in the acceleration due to gravity. Though the value of acceleration due to gravity is constant, 9.8 meter per second square, but when a body is taken to any places on the Earth's surface, the value of acceleration due to gravity varies, it changes. So change in the acceleration due to gravity will bring the change in the weight of the body. Okay, so with this we have come to the end of the chapter. Okay, and now we'll solve some numericals, okay, based on this chapter.